Let's get the show started. Thank you everyone for joining. Welcome to In Rhythm Lightning Talks. I'm Parag Katkar, your host for tonight. I'm the Senior Director of Enterprise Solutions at NRhythm. NRhythm Lightning Talks are hosted every Thursday at 5:15 p.m. Eastern Time. Each week, one of our practice area consultants share something that they learned recently or implemented, which will help you in your learning and growth. This week, Noah Hall, who is a senior engineer with us, is going to talk about Vagrant. And I'm really excited for this one. So let's get it started.
Yeah, thanks for the introduction, Parag. Hello, everyone. My name is Noah Hall. I've been engineering for quite some time. And today I want to talk to you about one of my favorite technologies, Vagrant. I got hip to Vagrant perhaps, I don't know how many years ago by one of my mentors, and I've been using it ever since. So let's go right into it. To give you an overview of what we'll be going through in this presentation, the first part is just general sense making to ensure we all have the requisite knowledge to further discuss the topics in part two, where we'll take a deep dive into Vagrant. And then part three, I'll talk about my vision for the future of not only Vagrant, but just the technology landscape in general. So let's go straight into part one. Sense making, foundational terms for virtual worlds. So virtualization, what is it? Where did it start? We almost have to start the conversation with emulators. And in computing, an emulator is hardware or software that enables one computer system called the host to behave like another computer system called the guest. So some examples would be printers. For example, the HP printer is the boss in the printing market. And a lot of other printing brands are capable of running HP software or mimicking or emulating HP printers, so that if you have a system that's designed to work with HP printers, it could also work with a Canon printer, etc. And that's a form of emulation. Another form of emulation that perhaps my gamers are knowledgeable about is, since the early 1990s, you could emulate old school arcade games from the 80s. Or for example, on your computer system, you could get a PS4 emulator, or my favorite, SNES emulator to play Mario. But to go even a bit further back in the way back time machine, the first functional simulators, another kind of emulator, was written by a company called Autonetics in about 1960 for testing assembly language programs for later execution in military computers. So this virtualization, which is a very hot term these days, has been around for a very long time. And it's really good to get the conceptually, as well as the historical foundation of virtualization. So the next kind of virtualization are hypervisors. And again, a hypervisor is an emulator. It's a kind of emulator. There are generally two kinds of hypervisors, but it's still an emulator. So it's just computer software or firmware that creates and runs virtual machines. A computer on which a hypervisor runs one or more virtual machines is called a host machine. And each virtual machine is called a guest machine. So type 1 hypervisors on your right, they're native or bare metal hypervisors. And these hypervisors run directly on the host hardware to control the hardware and to manage guest operating systems. The first hypervisors, which were developed by IBM, again, were in the 1960s. So we have some examples of modern type 1s, and these include Hyper-V by Microsoft, VM Server by Oracle, as well as the kernel-based virtual machine, KVM. Type 2 hypervisors on the left, these hypervisors run on top of existing operating systems, just as regular computer programs do. A guest operating system runs as a process in the host and abstract guest operating systems from the host operating system. Some examples of modern type 2s include Parallels Desktop, QEMU, VirtualBox, VM Player, and VM Workstation. The main difference or the main distinction between type 1 and type 2 hypervisors are where they operate. Type 1s interact directly with hardware resources, whereas type 2 hypervisors, they sit on top of the host operating system and enables you to run multiple versions of guest operating systems. I really wanted to dive into the distinction between hypervisors and containers, as there can be some confusion between the two. And one of the most significant differences between hypervisors, either type 1 or type 2, and containers, we can use Docker as an example, is the way they boot up and consume resources. So containers work on the host kernel. So you can't create multiple instances of an operating system within a single container. Generally, if you need multiple containers, you would use an orchestration platform, for example, Docker Compose, to create multiple instances of a container. However, with hypervisors, since they run on top of the hardware or on top of the host operating system, you can create multiple instances. And the use cases are a bit different as well. So you can tell from the image I have here, hypervisors are generally used for creating instances of operating system environments, whereas containers creates instances of applications and libraries. With that being said, you can once you create your operating system, you can, via a hypervisor, you can have multiple instances of applications. So now that we have a common foundation in which to discuss Vagrant, my advertising professor used to always say that good products, good people are generally known for one thing, and that stayed with me. And so if I were to say, what's the one thing about Vagrant? It's, development environments made easy, as it's primarily used for managing hypervisors, those type 1s and type 2s we discussed earlier. And Vagrant is a tool for building and managing virtual machine environments in a single workflow. So whenever I see Vagrant and we go out to dinner and he asks me, do you really know me? I say, well, if I have to give a one-liner for you, it's that Vagrant provides easy to configure, reproducible, and portable work environments built on top of industry standard technology and controlled by a single consistent workflow to help maximize the productivity and flexibility of developers. Again, it's for development. We're developers. It's really cool. And even though the focus for this presentation will be on Vagrant's use to manage hypervisors, it can manage any virtual machine. And this includes Docker images and the containers built from them, as well as through provisioners, you can manage Kubernetes clusters. And this capability brings a unified workflow to development environments and the applications within those environments. Just to dive in deeper, so for managing virtual machines, you could see here from the graph that on your host machine, you could have Vagrant, and via Vagrant, you could provision or create multiple guest OSs, and these OSs could be VMware or VirtualBox or Docker. And then within those guest environments, you can have on your host computer a Windows 10 machine, CentOS. You can launch containers with applications, as well as different Mac OS versions, as Vagrant has multiple providers for almost all major operating system distributions, and those providers have multiple plugins and provisioners where you could launch almost any application. To talk about Kubernetes is really, really hot. You can use Vagrant to manage Kubernetes clusters. While there isn't a Kubernetes provider directly, through a provisioner, for example, Ansible, you could provision Kubernetes and initialize it on boot or on the initial boot or every time the guest OS is started. there's deep customization. And this is one of the main use cases that I constantly go back to Vagrant, because perhaps this year I'm into JavaScript. Last year I was really into Ruby. A couple years ago, wow, I don't know, 10 years ago, I was really into PHP. But Vagrant has use cases for all of those, not only programming languages, but as well as the operating system that you'll be using, as well as integration with many providers and provisioners. And here you'll see like the general workflow, and it's difficult to really explain just the amount of customization, because I actually searched to say, hey, what can't I use with Vagrant? And honestly, I spent maybe 5 or 10 minutes and I couldn't find anything that did not already have a plugin or a provisioner or a provider, as well as, workflows for integrating with cloud technologies and cloud frameworks, for example, OpenStack or IBM, Microsoft Azure, AWS. There's the possibilities are limitless. And for everything that I'm interested in, and as well as some of the leading technologies, there was always something available with well-defined structure and a lot of community supporting it. So Vagrant's a industry staple that should be part of, in my perspective, a lot of developers' tool belt. Great. So we got through the high level, some of just the sense making on, what are hypervisors? Where do they come from? And this idea of emulators and, the distinction between hypervisors and containers, as well as diving into some use cases for Vagrant. So let's now dive into Vagrant itself and talk about some Vagrant first principles. I know first principles is a really hot topic for a few years now. And, for me, I like to apply that from the way I work and the things that I use and say, well, what's the first principle for development? Or what's the first principle for Vagrant? So we'll dive into what are the 5 key things for understanding Vagrant. And this is almost a prereq. Having this knowledge is foundational to really utilizing Vagrant. Great. So boxes and clouds. A Vagrant box is it's like a base image or a starting point of a development environment. There are boxes for every OS. I mean, Windows, Linux, and Mac OS, and the different versions of those operating systems. Now, these boxes, again, just space images, starting points of development environments. A box can contain practically everything a developer needs, or everything a development environment needs. And these applications and operating systems are generally pre-configured, but there's ways to modify the base box and create a new one that contains environment-specific configuration and applications for your particular use case. With these boxes, you can create, modify, import, extend, and share boxes publicly and privately. Boxes also support versioning so that members of your team that utilize Vagrant can update the underlying box configuration and application seamlessly and share those modifications with the rest of the team. Vagrant Cloud serves as a public searchable index of Vagrant boxes. It's like your public repository of all of the boxes that other people's and Vagrant and different companies have created and shared for public consumption as part of the Vagrant community. On Vagrant Cloud, it's easy to find boxes you can use with Vagrant that contain a wide range of technologies that you need for any sort of development. And the cool thing about Vagrant, specifically Vagrant Cloud, is that you don't even need a cloud account. Like, you don't have to sign up to utilize a box that you find on Vagrant. So that's a cool thing about HashiCorp and Vagrant, and how they've enabled just the use cases of, or the consumption of Vagrant, to make it as easy as possible for people. Again, so Vagrant Cloud is the public repository. It contains most major operating systems as base boxes, as well as specialized boxes for specific architectures and tech stacks. And the people who create boxes can push fixes, and people who use those can retrieve and get those fixes pretty handy. I know that would have been really helpful with all of this log4j stuff, if we could just pull one person and could create the correct patch and not a patch with the defects, and everyone could consume it. So great, that was Vagrant Boxes and the cloud. The next thing we'll talk about are providers. This is a previous image that I've used, but we could see that there's in the Vagrant DSL, well, there's a host machine, there's a Vagrant DSL, then there's Vagrant, and within that Vagrant environment, you have these providers. And providers are like plugins that enable Vagrant to manage different types of virtual machines. You can even create your own custom provider. Some examples of providers: VirtualBox, Hyper-V, Docker. There's a lot of stuff. I definitely recommend that you check out Vagrant Cloud and see those different providers that are available. And Vagrant Provisioners. So provisioners allow you to automatically install software or alter configurations within your development environment. And these provisioners can be configured to run just on the initial boot, so that after on subsequent boots, the applications are configured and the libraries are configured as it was the first time you started it, or on every boot. So for example, if there's a task or configuration that needs to run every time a development environment is started, provisioners can be used for that use case. Provisioners enable you to automate the development environment setup so that it's repeatable for everyone using the box. So if there's a change somewhere downstream and there's 5 developers utilizing this environment, the provisioner can retrieve those changes in an automated fashion the same way for everyone utilizing that development environment, and so that it's repeatable for everyone. There are many types of provisioners. Basically, any tech you already use can be used with Vagrant. If you're a command line hero, you can create provision scripts with Shell. You can use Ansible, Packer, Docker, Chef, Podman, Puppet, the list. There's Terraform. There's so many customizations and different provisioners and ways to enable custom startup scripts for development environments that can be shared across a team and each developer. The fourth thing is the Vagrant CLI. So there isn't a GUI for Vagrant. This is a command line tool. However, that doesn't mean once the guest OS is started, there isn't a GUI. Vagrant providers, depending on which one you're using, generally have both a headless tool, or it has a GUI tool, so that once the guest OS has started, you're either Vagrant SSHing in, or you could manage or utilize the development environment with your keyboard and mouse. And on the left, you see there's a few Vagrant commands, and these are the most important. Pretty simple. There aren't a lot of options for each command, and they work pretty seamlessly. I've yet to encounter a bug utilizing Vagrant, and it's been out for a while, so the API is pretty stable. Vagrant file. So this is the meat and potatoes of your guest OS. Via Vagrant files, this is how you define your environment, how your environment will be provisioned. You can have different provisioner scripts. You can configure your network. You can configure how shared folders or how folder synchronization occurs from your guest OS to your host machine. And this is actually a copy of the exact Vagrant file that I utilize for all of my environments on my host machine that I use, whether it's a private repository or excuse me, whether it's I'm working in a public repository or private repository. This sets some really great defaults for me so that I can be sure my host machine is secure and private and isolated from the guest machine. So this is available on my GitHub. You'll see that's in the top right. Great. So we talked about the history of virtualization, the distinction, the types of hypervisors, as well as the distinctions between hypervisors and containers. We also took a lightning talk into the Vagrant API, some of the specifically the foundational aspects of using Vagrant. The 5 key things were Vagrant Boxes and Vagrant Cloud, Vagrant Providers, Vagrant Provisioners, the Vagrant CLI, and Vagrant Files. So let's see what's next. Well, if you ask me what you should be focusing on for the next 5 years, I would say the virtualization, continue your deep dive into virtualization and cloud. Cybersecurity is only getting more important, especially with the lack of knowledge for generally in the development community. Web3 and metaverse, I know some people think they're just high-pitched marketing, but I think they are ready for scale. I know Web3, some of the technology behind Web3 and metaverse and augmented reality has been out for quite some time, but the general technology foundation that makes it available to scale in an enterprise, from an enterprise perspective, I think we're coming around to that. We're going to be seeing much more adoption with Web3 platforms and the metaverse. Quantum computing, that's huge. You can already take like classes and learn how to utilize that. And I know specifically for cybersecurity and a lot of our privacy practice, they're not, may not be as ready for the onset of the quantum computing. AI, ML, generally don't think there's any hope for general AI or the next 50 years, but AI specifically, not general artificial intelligence, but just AI and ML. I think there's a lot of things happening from that on that end as well. These are the 5 things that I will be focusing on, and I hope to motivate everyone in my community to focus on these aspects as well.